Did you know that avocado contains more bioavailable glutathione than any other plant food studied, and that this glutathione reaches liver cells in usable form? Today, I will show you the 7 fruits whose compounds science has associated with hepatic support and inflammation reduction, ranked from least to greatest clinical evidence, and how to include each one in your diet in the way that maximizes benefits. Before starting the ranking, a concept that organizes everything. The liver has 2 main systems for eliminating toxic compounds: the phase 1 system, mediated by the cytochrome P450 enzymatic complex, especially CYP3A4, converts lipophilic substances into more polar metabolites. The phase 2 system, mediated by enzymes like glutathione S-transferase, sulfotransferase, and UDP-glucuronosyl transferase, conjugates those metabolites with polar molecules like glutathione, sulfate, and glucuronic acid, making them water-soluble for excretion through bile or urine. When these systems are compromised by aging, steatosis, or chronic inflammation, intermediate metabolites accumulate and cause oxidative damage in liver cells. The fruits on this list contain compounds that act directly on these systems. Understanding this is understanding why these fruits matter for the liver in a way that goes far beyond the popular cleansing narrative. Fruit number 7. Prune or plum. Plum contains a combination of compounds with specific liver relevance that is frequently underestimated. Chlorogenic acid, the main phenolic acid in plum, modulates the phase 2 hepatic detoxification enzymes, especially glutathione S-transferase. A study in the Journal of Agricultural and Food Chemistry demonstrated that chlorogenic acid increases glutathione S-transferase activity in hepatic tissue, facilitating the conjugation of toxic metabolites with glutathione and their subsequent elimination through bile. This mechanism is particularly relevant for people over 60, as hepatic glutathione S-transferase activity declines with aging, and this decline is one of the factors that make the liver more vulnerable to toxic accumulation and oxidative stress. The second relevant compound is sorbitol, which increases intestinal motility and reduces transit time. This has indirect but important hepatic relevance. When intestinal transit is slow, bacterial lipopolysaccharides have more time to be absorbed through the intestinal mucosa and reach the liver via the portal vein, increasing the hepatic inflammatory load. The isomers neochlorogenic acid and cryptochlorogenic acid have documented anti-inflammatory effects through COX-1 and COX-2 inhibition in hepatic tissue. Dried plum concentrates all these compounds more than fresh fruit. 3 to 5 dried prunes equal the chlorogenic acid content of 10 fresh plums. Patricia was 68 years old, a retired teacher from Phoenix with ALT of 64 and chronic constipation. With 4 dried prunes per day for 12 weeks, ALT dropped to 51 and intestinal transit normalized. How to include 3 to 5 dried prunes per day, preferably in the morning. Fruit number 6. Papaya. Papaya, Carica papaya, has 2 groups of compounds with documented hepatic action. The first group is proteolytic enzymes, papain and chymopapain, which degrade misfolded proteins and protein aggregates in hepatic interstitial fluid, contributing to a protein-clearing function that a compromised liver executes with reduced efficiency. The second group is lycopene, responsible for the orange-red color. A study in the British Journal of Nutrition showed that regular consumption of lycopene-rich foods is associated with lower degrees of hepatic inflammation. The mechanism: lycopene inhibits the activation of hepatic stellate cells, the cells responsible for collagen deposition and the fibrosis process that transforms steatosis into cirrhosis. Additionally, papaya is rich in ascorbic acid and flavonoids that contribute to hepatic glutathione synthesis. Papaya seeds contain carpacemine and benzyl isothiocyanate, with documented hepatoprotective effects in animal models. Frank was 73 years old, a retired farmer from Sacramento, with ALT of 71, AST of 58, and grade 1 steatosis. With half a ripe papaya per day for 16 weeks, ALT dropped to 55. How to include half a ripe papaya per day. Consume with seeds. Crush 1 teaspoon of seeds and mix into the flesh. Fruit number 5. Blueberry. Blueberry, Vaccinium myrtillus, is the fruit with the highest anthocyanin concentration among common fruits, and anthocyanins have the largest body of clinical evidence in humans for direct hepatoprotective effect among all fruit polyphenols. Blueberry anthocyanins, especially cyanidin 3-glucoside, delphinidin and malvidin, have 3 documented hepatic mechanisms in human studies. First, hepatic NF-κB inhibition. Anthocyanins inhibit the activation of nuclear factor kappa B in liver cells, reducing production of inflammatory cytokines TNF-alpha, IL-6, and IL-1 beta, the primary mediators of steatosis to steatohepatitis progression. Second, NRF2 receptor activation, the main regulator of cellular antioxidant response, which induces expression of genes encoding phase 2 detoxification enzymes. In practical terms, anthocyanins make the liver produce more of its own antioxidants and protective enzymes. Third, gut microbiome modulation. Anthocyanins alter microbiota composition in ways that increase butyrate and propionate production. Short-chain fatty acids with direct anti-inflammatory and anti-lipogenic effects in liver cells. A randomized clinical trial published in Nutrients followed 49 patients with non-alcoholic fatty liver disease for 12 weeks. The standardized blueberry extract group showed significant reduction in ALT, AST, hepatic triglycerides, and systemic inflammation markers. The mean ALT reduction was 18 points. Margaret was 66 years old, a retired teacher from Phoenix, with ALT of 79 and grade 2 steatosis. With 150 grams of fresh blueberry per day for 14 weeks, ALT dropped to 58 and AST from 61 to 44. How to include 100 to 150 grams of fresh or frozen blueberry per day. Wild European blueberry has 3 to 4 times higher anthocyanin concentration than cultivated American varieties. Tell me in the comments where you are watching from right now. Write the name of your city. And if you have not yet subscribed, click the button and turn on the bell. Fruit number 4. Grapefruit. Grapefruit, Citrus paradisi, is the fruit on this list with the most specific and pharmacologically relevant mechanism of action, and also the one requiring the most attention regarding drug interactions. Grapefruit contains naringenin and naringin, flavonones in the juice and pulp, and bergamottin and dihydroxybergamottin, furanocoumarins in the essential oil of the peel and in smaller amounts in the juice. These compounds inhibit the CYP3A4 enzyme, the main cytochrome P450 enzyme that metabolizes over 50% of all existing medications. When CYP3A4 is chronically hyperactivated, as happens in people with hepatic steatosis, it generates reactive intermediate metabolites that cause oxidative stress in liver cells. Partial and controlled CYP3A4 inhibition by naringenin and furanocoumarins reduces this excess activity. A study in drug metabolism and disposition documented that grapefruit juice consumption before meals significantly reduced hepatic oxidative stress markers. Additionally, naringenin has direct effects on hepatic lipogenesis. It inhibits FASN gene expression and activates the PPAR alpha receptor. A clinical trial in the Journal of Nutritional Biochemistry showed that NASH patients who consumed naringenin for 12 weeks had significant reductions in ALT, AST, and imaging-measured steatosis. The fundamental warning: furanocoumarins that inhibit CYP3A4 also inhibit the metabolism of medications that are substrates of this enzyme: statins, calcium channel blockers, anticoagulants, immunosuppressants, and some antidepressants. Anyone taking regular medications must consult their doctor before adding grapefruit. How to include for those without drug contraindications: half a grapefruit in the morning or 200 ml of natural juice without added sugar. The pulp and white membrane have higher naringenin concentration. Fruit number 3. Red or purple grapes. Red grapes already appeared in the lymphatic video. For the liver, the most relevant compound is resveratrol, concentrated mainly in the skin and seeds of red and purple grapes. Resveratrol has 4 mechanisms documented in human studies. First, SIRT1 pathway activation, sirtuin. 1 regulates hepatic cell metabolism, including mitochondrial biogenesis, fatty acid beta oxidation, and lipogenesis inhibition. When SIRT1 is activated by resveratrol, liver cells oxidize more fat and accumulate less. Second, NLRP3 inflammasome inhibition, which maintains the persistent hepatic inflammation characteristic of steatohepatitis. Resveratrol inhibits NLRP3 activation and reduces IL-1 beta production. Third, hepatic AMPK activation, de novo lipogenesis inhibition, and beta oxidation stimulation. Fourth, gut microbiome modulation toward bioactive metabolites with anti-inflammatory effects in liver cells. A meta-analysis in Nutrients analyzed 12 randomized clinical trials with resveratrol in NAFLD patients and found significant reductions in ALT, AST, HOMA-IR index, and imaging-measured liver fat. Important note, the highest resveratrol concentration is in the skin and seeds. Red wine is not recommended as a hepatic strategy. Alcohol's effects on the liver outweigh any polyphenol benefit. How to include 150 to 200 grams of red or purple grapes with skin and seeds per day. Chew the seeds gently. Fruit number 2, lemon and citrus fruits. Lemon already appeared in the morning drink video. In this video, the context is different. Lemon as regular food. The additional relevant compound for this ranking is diosmin, abundant in the albedo, the white layer between the peel and the pulp, and in the white membranes surrounding the segments. Diosmin has documented hepatoprotective effects through multiple mechanisms. The primary one in this context is protection against lipid peroxidation in hepatic cell membranes. Lipid peroxidation is one of the main cellular damage mechanisms in steatosis. When excess fat in liver cells reacts with free radicals, malondialdehyde forms an oxidative damage marker that directly damages membranes and DNA. Diosmin has specific antioxidant effect against lipid peroxidation in hepatic tissue, documented in the Journal of Functional Foods. Diosmin and hesperidin also have hepatic anti-inflammatory effects through TNF-alpha and IL-6 inhibition. A surprising fact, most of the diosmin and hesperidin in citrus fruits is in the albedo and white membranes, exactly the parts people habitually discard. Eating the whole orange with the white pith, not discarding the white part of lemon when making juices, using zests and peels in culinary preparations. These simple practices multiply the active flavonoid content ingested. Frank Sr. was 71 years old, a retired businessman from Cleveland with ALT of 82, elevated LDL, and mild steatohepatitis. With 1 whole orange with white pith daily plus lemon zest in food for 16 weeks, ALT dropped to 63 and triglycerides reduced significantly. How to include 1 to 2 citrus fruits per day, whole orange with white pith, pomelo, tangerine, or lemon in the morning juice. Use peels in rice, soups, and sauces. Fruit number 1, avocado. Avocado, Persea americana, is the number 1 fruit on this list for a specific and documented reason. It is the only fruit with preformed glutathione in nutritionally significant quantities, and avocado's glutathione reaches liver cells in biologically usable form. Glutathione is the main intracellular antioxidant in liver cells. It acts as the main scavenger of toxic metabolites within hepatocytes, conjugating reactive compounds and making them water-soluble for excretion. It also regenerates other antioxidants, vitamin C and vitamin E, after they react with free radicals. The problem with dietary glutathione is that most food sources are degraded by gastric and intestinal digestion before being absorbed. Proteases cleave the peptide bond linking the 3 amino acids, glycine, cysteine, and glutamate, that form glutathione. In avocado, glutathione is protected by a lipid matrix that reduces exposure to digestive proteases during absorption. Biokinetic studies in humans, including work published in the Journal of Nutrition, demonstrated that avocado consumption results in measurable increases in plasma glutathione levels, unlike what occurs with most other glutathione-rich foods. Avocado contains between 27 and 31 mg of glutathione per 100 grams of flesh, concentration comparable to low-dose glutathione supplements. Beyond glutathione, avocado has 3 other compounds with direct documented hepatic relevance. First, oleic acid, the predominant monounsaturated fatty acid, activates the PPAR-alpha receptor in liver cells and stimulates fat beta oxidation. Second, beta-sitosterol, a phytosterol, competes with cholesterol for intestinal absorption and reduces LDL cholesterol levels. Lower LDL levels mean less substrate available for liver fat formation. Third, avocado's glutathione acts as a direct substrate for phase 2 detoxification enzymes, especially glutathione S-transferase. A classic Japanese study and a more recent meta-analysis in Nutrients found significant reductions in ALT, AST, and multiple hepatic markers with regular avocado consumption in people with steatosis. Patricia grandmother was 69 years old, a retired seamstress from Atlanta with ALT of 94, AST of 72, and NASH with active inflammation. With half an avocado daily for 20 weeks, consumed with the main meal, not as juice, ALT dropped to 67 and AST to 52. How to include half to 1 avocado per day consumed with a meal. Avocado fat enhances absorption of fat-soluble vitamins A, D, E, and K from other foods. Hass avocado has higher glutathione and beta-sitosterol concentration. Do not make avocado juice with milk or sugar. Preserve with the pit and lemon to slow oxidation. Summary of the 7 fruits with their key compounds. Plum, chlorogenic acid, glutathione S-transferase activation, plus reduced portal inflammatory load. Papaya, papain plus lycopene, interstitial proteolysis, plus stellate cell inhibition, plus hepatic anti-inflammatory. Blueberry, anthocyanins, NFKB inhibition, plus NRF2 activation, plus microbiome modulation. Largest body of clinical trials among fruits, grapefruit, naringenin plus furanocoumarins, CYP3A4 modulation, plus FASN inhibition, plus PPAR alpha activation, attention to drug interactions, red grapes, resveratrol, plus OPCs, CYRT1 activation, plus NLRP3 inhibition, plus AMPK activation, lemon and citrus, iriocitrin, plus diosmin, plus hesperidin, plus vitamin C, lipid peroxidation protection, plus glutathione synthesis, plus choleretic. Avocado, preformed glutathione, plus oleic acid, plus beta-sitosterol, direct phase 2 detoxification, substrate, plus hepatic beta, oxidation, plus LDL reduction. Action plan for including these fruits in your routine. Monday and Thursday, blueberry, 100 DRE each day. Tuesday and Friday, avocado, half avocado with main meal. Wednesday, grapefruit in the morning, without drug contraindication. Saturday, red or purple grapes with skin and seeds, 150 DRE. Sunday, papaya with seeds, half papaya. Every day, 1 citrus fruit, 3 to 4 dried prunes on any day of the week. Laboratory follow-up plan. Before starting, request ALT, AST, GGT, triglycerides, fasting glucose, fasting insulin, HOMA-IR, LDL, and HDL. Repeat at 12 weeks. At 24 weeks, request abdominal ultrasound if there is improvement. A systematic review published in Antioxidants in 2023, analyzing 47 clinical trials on fruit polyphenol interventions in NAFLD patients, concluded that regular consumption of fruits rich in anthocyanins, resveratrol, and citrus flavonones is associated with clinically significant reductions in ALT, AST, hepatic triglycerides, and systemic inflammation markers, with the greatest documented effects for blueberry anthocyanins, grape resveratrol, and grapefruit naringenin. The adoption of a dietary pattern with at least 3 to 4 weekly servings of fruits with high hepatoprotective polyphenol density produces an effect comparable to conventional hepatoprotective herbal treatments in terms of ALT and inflammatory marker reduction. Quantity matters. Studies using less than 100 grams of blueberry per day or less than 30% of avocado per meal showed smaller effects. Adequate quantity, regularity, and consistency are the 3 determining factors. Complete action plan for integrating these fruits into your routine. The goal is not to consume all 7 every day. It is to create a rotation that ensures regular exposure to at least 3 to 4 of these fruits each week. Suggested weekly rotation: Monday and Thursday, blueberry, 100 dream each day. Tuesday and Friday, avocado, half avocado with the main meal. Wednesday, grapefruit in the morning, without drug contraindication. Saturday, red or purple grapes with skin and seeds, 150 g. Sunday, papaya with seeds, half papaya. Every day, 1 citrus fruit, whole orange with white pith, pomelo, or lemon in morning juice. Dried prunes, 3 to 4 units on any day of the week, preferably in the morning. About timing. Avocado is best with meals because of the fat that protects glutathione. Citrus fruits are better between main meals, so citric acid acts in the stomach without competition from dietary proteins. Blueberry can be consumed at any time. Grapefruit is best in the morning before breakfast. The most sensitive markers to fruit interventions: LDL cholesterol, avocado and citrus, triglycerides, blueberry and resveratrol, HOMA-IR, resveratrol and anthocyanins, and ALT, multiple compounds, typically respond first, generally with detectable changes between 8 and 12 weeks of consistent intervention. Regarding quantity, the clinical evidence consistently shows that doses below 100 grams of blueberry per day or below half an avocado per meal produce smaller and often statistically non-significant effects. Do not divide the portions into very small amounts thinking you are getting the same benefit. Concentration and consistency are what drive results. A final thought on the synergy of these fruits when combined. When you consume several fruits from this list, they do not act independently, they act synergistically. Blueberry anthocyanins and grape resveratrol both modulate the gut microbiome, but through different bacterial strains. Blueberry favors Akkermansia, mucinifera, and Lactobacillus species. Resveratrol favors Bifidobacterium and Faecalibacterium prausnitzii. When both are consumed together, a more diverse and protective microbiota emerges that produces more butyrate, a short-chain fatty acid that reaches the liver through the portal vein and has a direct anti-inflammatory effect on hepatocytes. Avocado glutathione works synergistically with citrus vitamin C. Vitamin C regenerates oxidized glutathione back to its active form, while glutathione regenerates vitamin C after its reaction with free radicals. Together, they form a dual antioxidant system in liver cells significantly more efficient than either alone. Naringenin from grapefruit and resveratrol from grapes both activate the SIRT1 pathway, but through different binding sites. Their combined effect on SIRT1 is additive. These synergy mechanisms are another reason why varied consumption of these fruits in combination brings greater benefits than daily consumption of a single fruit at the same total dose. My friend, the liver has an extraordinary capacity for regeneration when it receives the right substrates. These fruits are not supplements, they are foods with bioactive compounds acting on real and documented mechanisms. Add avocado to today's salad, put a whole orange with white pith in tomorrow's breakfast, buy a handful of blueberries, and in 12 weeks get your tests done to measure what changed. God bless you and give you much health. Until next time.